The universe. It was born in a flash of light and fury, the Big Bang. Galaxies formed, stars ignited, and life emerged. But what if it all ends the same way it began, only in reverse? Imagine this. The universe is expanding now, but what if, one day, gravity wins? What if all the galaxies, stars, and space itself stop stretching and start shrinking? The Big Crunch is the theory that the expansion of the universe could someday halt and reverse. Under its own gravitational pull, the universe would collapse inward, galaxies would converge, stars would collide, and space-time itself would fold back into a singularity. This idea isn't just poetic, it's backed by physics. First proposed in the early 20th century by Russian physicist Alexander Friedmann, the Big Crunch emerges naturally from Einstein's equations of general relativity under the condition that the universe contains enough mass. It would be, quite literally, the end of everything and perhaps the start of something entirely new. But how would it actually unfold? This theory hinges on a concept called critical density, a tipping point in cosmology. If the amount of matter and energy in the universe exceeds this critical value, gravitational forces would eventually overpower expansion and reverse it. At first, the signs would be subtle. Distant galaxies would slow their retreat. One by one, they'd stop moving away and begin creeping closer. The background radiation temperature would rise. Entropy would shift into reverse. Imagine billions of years ticking by. Galaxies that once fled from each other now start to fall back. The cosmic expansion halts. Then it begins to shrink. As time progresses, the collapse would accelerate. Galaxy clusters would merge violently. Stars, drawn into tighter orbits, would collide and explode. Black holes would devour matter and grow enormous. The cosmos would become hotter, denser, and more chaotic. Eventually, atoms themselves would be torn apart. Fundamental particles crushed together. Time would warp. Space would curl in. Black holes would combine into supermassive singularities. And finally, the universe, everything we know, would disappear into an infinitely dense point, a singularity, a fireball marking not just the end, but potentially the rebirth of the cosmos. This moment wouldn't just be hot, it would be cosmically incandescent, a collapse so intense that temperatures would surpass even those at the Big Bang. The Big Crunch is deeply rooted in Einstein's general relativity, which describes how mass and energy shape the geometry of space-time. If the average density of the universe is higher than the critical value, estimated to be around 10 to the negative 29th power grams per cubic centimeter, then expansion slows and reverses. For much of the 20th century, astronomers raced to determine this density. Was our universe closed, flat, or open? In a closed universe with high density, gravity dominates. The expansion eventually stops and contracts. For a time, this seemed plausible. But then in the late 1990s came the surprise: dark energy. Scientists observing distant Type Ia supernovae discovered that the universe's expansion wasn't slowing, it was accelerating. Dark energy, a repulsive force with negative pressure, appears to make up about 68% of the universe. It acts against gravity, pushing galaxies apart faster and faster. This discovery threw a wrench into the Big Crunch scenario. It transformed our understanding of the cosmos. Yet dark energy is poorly understood. It's the most dominant force in the universe and the most mysterious. Is it constant? Could it change? Could it vanish? This uncertainty leaves the door open for scenarios like the Big Crunch. Here's the twist: dark energy is mysterious. We know it exists, but we don't understand what it is or how stable it might be. Some physicists propose that dark energy could decay or change over time. If its repulsive effect weakens, gravity could reclaim dominance. One theory, called quintessence, suggests that dark energy might be dynamic, waxing and waning through cosmic epochs. In such a scenario, expansion could halt, reverse, and the universe could tumble into a catastrophic collapse. Another idea? That the current acceleration is just a phase, one that might one day end. There's even speculation that in a far future, dark energy could flip signs, becoming attractive rather than repulsive, pushing the universe into a crushing collapse. The collapse might start billions or trillions of years from now, but once begun, it would be unstoppable. Let's imagine the final era of the universe as the Big Crunch begins. Galaxies spiral into each other, massive cosmic collisions light up the shrinking night sky. Stars, too close for comfort, devour one another in tidal waves of gravity. Black holes merge into titanic beasts. Radiation floods the cosmos. There is no cold, there is no dark. Every structure, solar systems, planets, molecules, is ripped apart. The cosmic background radiation intensifies, eventually bathing the universe in searing light. Even quarks, the building blocks of matter, melt into a featureless sea. And then the fire. All space, time, matter, and energy collapse into a single point of infinite density and temperature. A singularity that signals the end of everything, or the beginning of something new. The story doesn't necessarily end with a crunch. In fact, it could begin again. Some theories in quantum gravity suggest that the singularity at the heart of the Big Crunch might not be an end, but a bounce. Loop quantum cosmology and some string theory models propose a rebounding universe. This leads to the idea of the Big Bounce, a cycle where each universe's death triggers another's birth. Instead of a single, linear timeline, the cosmos may be eternal, oscillating forever between expansion and collapse. In these models, what we call the Big Bang wasn't the beginning, it was the rebound of a previous universe's end. Our universe might be just one iteration in a chain of infinite universes, each rising and falling like the breath of a cosmic being. This isn't science fiction. It's speculative, yes, but it's grounded in cutting-edge physics and our quest to understand the origin and fate of all things. The Big Crunch is just one possible fate. Other theories suggest different endings: the Big Freeze, where the universe continues expanding forever, slowly fading into a cold, dark void. The Big Rip, where expansion accelerates until it tears galaxies, stars, planets, even atoms apart. The Vacuum Decay, where a quantum instability causes reality itself to collapse at light speed. Compared to these, the Big Crunch is almost comforting. It's hot, yes, but it's familiar, it's cyclical, it might even lead to rebirth. So how will the universe end? Will it freeze in silence, rip itself apart, or collapse in one final cosmic breath? We may never know, but the search for answers fuels the very spirit of science. If this cosmic journey lit up your mind, give the video a like, subscribe for more explorations into space and time, and leave a comment below. Will the universe end in a big crunch, a big rip, or something even stranger? Stay curious and keep looking up.